Okay. So today, what we have done on Thursday, we've done the linear regression and we've done the quadratic regression, right? So today we're going to talk about exponential models. So exponential models represents quantity that change at a constant percent rate. So with linear, it was a constant rate. So let's say if you start with, you're going up by 9, so you're adding 9 every single time, okay? With quadratic, it was the second difference that was constant. So we had to do two differences, not only one. First one would be not constant, the second one would be constant. When we're talking about exponential model, we're talking about a change with a constant percent rate. So it's a rate. It's not addition or subtraction. It's a percentage rate. So in a table of values, the growth or decay factor are equal. So remember that we talked about in linear and quadratic, it was the first difference and the second difference that they were equal, right? In this case, in the exponential, it's the growth and decay factors. The graph resembles an exponential curve. So it would look like this, right? Where it's a slow growth at the beginning and then it grows fast, or it's a slow decay at the beginning and then it decays faster. The equation of the graph would look like this, where the x is the exponent, right? Where your variable is the exponent. What does A represent?
Initial.
Good. So A is the initial value. What does B represent?
Growth and decay factor.
That's right. And the exponent is the x, or it's the variable, right? So remember that we call B the growth factor, okay? But most of the time, the question doesn't give us the growth factor. The question gives us the growth rate. So we have to calculate the growth factor, right? Because you guys have to remember that my equation is actually y equals a
1 plus I x.
to the power of x, where 1 plus I is my b,
Yeah.
right?
Yeah.
That's if I have a growth question, right? So for growth,
Decay is minus.
right, where this right here represents your b, right? So the 1 plus I replaces the b. And when I have a a decay question, it will be 1 minus I to the power of x. Again, this will be replaced by b. Okay, so that's when I have a decay. Okay? You guys, if I ask you for the growth factor, I'm looking for b itself. So if I'm asking you what's the growth factor, you just look at b and tell me that it's that. But if I ask you for the growth rate, you have to do the math. Remember that table that I've given you on the test that passed,
Yeah.
right? I asked you what is your growth rate. So if you had, for example, if you had 1.08 as b, right? To find the growth rate, you had to do 1.08 minus 1. And then found the percentage, and that would be your growth
Yeah.
rate. So the growth rate, I'm looking for the percentage, which is the I, basically. Okay? So you have to be careful what I am asking for. Terminology is very important here.
Rate is a percentage.
The rate is a percentage, and you need to find the I.
Yeah.
Okay? very few people did that correctly on the test. Okay. So, if b is greater than 1, then the relation is
Growth.
growth. It's growth, right? So, as I said earlier, that your growth factor, which is b, right, is 1 plus the growth rate. So that would be 1 plus I, but in decimal. Now, if you want to find the growth rate, like the question that asked you that on the test, you had to do
1 plus
the growth factor, and sorry, you have, if you want to find b, no, that was right, never mind. If you want to find I, you take b and you subtract it from 1. Are you guys okay with this? Alright. Now, if it's between 0 and 1, if b is between 0 and 1, then I have
Excuse
dk.
me. I'm
Yes.
confused with the growth factor with the growth rate. What's the difference between them?
I'll tell you what's the difference between them in a moment.
Can say decaying? You can say decaying?
It is decaying, yeah. So why not? So if you have a question that looks like this, right? This right here is your growth
Growth, yeah.
factor. Okay?
Yeah, but this one is minus, right? 1 minus.
How is that one? That's a
This
point.
minus?
That's
Oh,
a
point, sorry. Yeah,
Okay, so that's your growth factor.
yeah, this is the.
How did you get that growth factor? How did we get 1.0802?
Because b is superior than 1.
So-
Maybe. How to get?
Yeah.
Is 1 plus I.
So to get 1 plus I, 1 plus I is 1.02, right? Because remember the formula, this is the formula. Right? Right? So basically this right here is 1.02, right? So 1 plus I is equal to 1.02. Are you okay with that? Okay, now the question is asking you, let's say, what is your growth rate? This is the growth rate. The growth rate is the I. It's the percentage that your thing is growing by. Okay? So to solve for I, I need to isolate for it. So I need to bring the 1 over. So that becomes I equals 1.02
Minus 1.
minus 1. I can't even write it. Right? And this is what I'm telling you here. To find the growth rate, you have to do the growth factor, which is 1.02, and take away 1 from it. Make sense?
Yeah.
Okay.
Just leave it this one. I want to write it. Please.
Are we okay with this? All right. So always remember that the factor is the 1 plus the I or the 1 minus the I. That's the factor. It's whatever you see in your formula. So to find the decay factor, right? We know that the decay factor is 1 minus the decay rate. So basically what I'm writing here, y equals a 1 minus I to the power of x. This is,
Is b.
this whole thing is b, which is my decay factor,
Yeah.
right? They're the same thing. Now the decay rate is also equal to 1 minus the decay factor. So if I want to find the decay rate,
The same.
I have to do 1 minus the decay factor.
The same.
Okay?
Isolate pi.
To isolate for I.
So which one we got like a percentage is like a 8%?
I is a percent.
I?
Is a percentage.
How to get I? The same thing? Like this one, it's I, right? So when you got the end of the...
Let's look at an example. Let's do an example here. One second. Let's do this example right here. That will clear things up for you.
Okay.
Okay? So the question right here is asking you to determine the growth or decay rate. So I'm looking for I. Right? Rate means I'm looking for I.
Yeah.
So let's look at the first one. Is it a growth or a decay?
It's a growth.
Growth. Good. So this is my B, right?
Yeah.
I. So B equals, sorry, I'm looking for I. I equals
1 plus...
5 and 9. Okay.
B minus 1,
Yeah.
right? Because B is bigger than 1, then I have to put B first and take away 1. So 1.071, take away 1, that gives me 0.071.
This is I, right?
This is I.
Okay.
But I should be in percent. How can I change this decimal to percentage?
Time 100?
Times it by 100 and we're done.
71?
7.0.
7.1.
Okay? So that means whatever thing that you have, it will be growing, okay, by 7.1%.
Okay.
How about the second one?
Decay.
Decay. Again, I am looking for I. This is what the question's asking me for. The question's asking me to find my decay rate. So I'm looking for I. I equals to what?
1 minus
1 minus what?
0.92.
1 minus B. So that will be 1 minus 0.92. So that would be 0.08. Is that clear?
So the decay, the
8%.
formula is I 1 minus I, right?
To find B.
To find B.
Okay. To find B, to find this, find B, it's 1 minus I.
Yeah.
To find I, it's 1 minus B. So you have two formulas that you don't need to remember it even. To find I, it's always you take 1 minus a small one, or you take the big 1 minus 1. So you have either B minus 1 or 1 minus B. If you get a negative number, you're doing something wrong. So switch it.
And the rate, when you ask me about the rate, I have to
You
time
have to change
100.
it to percent.
This is the rate, right?
That's the rate.
Okay.
Are you guys okay with it? So, if the question is asking you for rate, that means you're looking for I, that means you're looking for percentage. Figure it out.
We have this one next.
Huh?
They say we will have this in exam.
Yeah, this will be on a test, this will be on an exam. It was on your previous test. I already explained it last chapter, so it should be, Since we are on this page, let's look at these two. So the question is asking, it's a previous question, so which model represents exponential relation? Okay, so since we're here, let's start with this and then we'll go backward. Now, which one of these represents exponential relation?
B.
B. Okay, so this is an exponential relation. Why is that?
Because exponential. Exponential curve.
Because it's an exponential curve. How about the first one?
It's linear.
What do we call this? It's linear,
Consonant.
right? It's linear. It's a line, it's a straight line. Okay, so then let's write this then. So this is a straight line. So it's not exponential.
What do you mean exponential?
That means it grows slow first and it grows faster after.
Mhm.
Or it decays slow first and then decays slow after. But in this case, it's a growth.
Mhm.
It's what we did last chapter. We did exponential in the last chapter. How about E? Is E exponential or not?
E exponential.
It is exponential, and why is that?
Bracket.
So you're telling me this is exponential now?
No, but x we don't know if it's 1 or no.
Yeah. X don't have
Yeah.
any power.
So what do we call X?
Exponent.
So the exponent is what?
The second one, we know the f is
Variable.
exponential because the x is 2. The exponent is 2, number 2, is not number 1.
So let's
Exponential
think
is
about this one first.
F.
Is this exponential?
No.
Yeah.
We
I
don't
said
know.
no.
Yes, it is. No.
Why is it yes?
Because y is equal A
into B.
into B and X. Exponent.
So it looks like the equation y equals ab to the power of x.
Yeah.
What's the important part about exponential?
X.
X if is 1, equal 1 is straight right? No?
Yeah, but in this case, do I know what x is?
No, we don't know. This is what we
Exactly,
have. We
that's
don't know.
why it's an exponential. It's an exponential because your variable, your exponent is a variable, right?
Yeah.
You see how you have an exponent here,
Yeah.
and the exponent is a letter?
Yeah.
Whenever your exponent is a letter, that is exponential,
Mhm.
okay? So, how about the second one?
First
What is it then, if it's not exponential?
Quadratic.
It is quadratic, and why is it quadratic?
Because
It
two.
is, yeah,
Quadratic
there's a
is
letter
2.
2.
back to our table of values right here. So the question is asking which model represents exponential growth. So we talked about linear. If I have a table of value, how would I know it's linear? What do I have to do?
First difference.
What would I have to do to know if it's quadratic?
Oh, second difference.
Second difference. Now if it's exponential, I have to do a ratio. Okay? So with exponential, I have to do ratio. What's a ratio? What does the word ratio mean?
Proportion.
Ratio is y2 minus 1.
Divide. Divide.
Oh, yeah.
Okay? So for ratio, I have to divide. So instead of doing y2 minus y1, I have to do y2 divided by y1. Okay? So if my ratio is constant, so if I do y2 divided by y1, what do you get for the first
10.
one? No. 0.7.
0.7.
If I do y2 over y1,
0.6.
is my ratio constant? Okay, so ratio is not constant. Therefore, it's not exponential. Okay?
Here we have to divide.
Yes. If you want to find if it's exponential or not, you have to do the ratio. So this is the rule that we go with. If they give us a table of value and they ask us, is it linear, quadratic, or exponential? What do? First, you try your first difference. You do y2 minus y1. If it doesn't work, if it's not constant, then you do your second difference. Now, if the second difference is not constant, this is where you try if it's exponential. And then you do your division. You go back to the original y's, and then you divide y2 over y1.
Ratio.
Okay? So one of them has to be constant.
Is which one? Okay.
Okay? If none of them is constant, that means we call it a neither function, which could be a cubic, could be a quartic, could be logarithmic, could be, I don't know. Right? So then it won't be clear. So let's do the ratio here. So y2 over y1.
1.25.
Right, it's not 1. And the first one won't be 0.66. This is wrong. 0.66. So, you see how my ratios are constant here? So that means it's an exponential function. We call it first ratio, but you don't have, just you can say it ratio.